Hi guys, welcome to my YouTube channel. In this video, we solve routine integral using principal value. So we have integral from 0 to 1 of -1 raised to power x dx. So let's start. So by Euler formula, we have exponential of iota theta is equal to cos theta plus iota sin theta. Let us put theta is equal to pi. So we have exponential of iota pi is equal to cos pi plus iota sin pi, which is equal to -1 as sin pi is 0. We can write this as -1 is equal to exponential of iota pi. Now we are going to raise both sides of power x. Now we have -1 raised to power x is equal to exponential of iota pi and x, which is equal to exponential of iota pi x. Now we put this value in our integral. Now we have integral from 0 to 1 of -1 raised to power x dx is equal to integral from 0 to 1 of exponential of iota pi x dx. Now integral of exponential of iota pi x is equal to exponential of iota pi x upon iota pi, and limits are 0 to 1. Now we do upper limit minus lower limit. So we have exponential of iota pi upon iota pi minus 1 upon iota pi. Now we solve this. As exponential of iota pi is equal to -1, so we have -1 upon iota pi minus 1 upon iota pi, which is equal to -2 upon iota pi. Now we further solve this to make it in a simple form. So we multiply and divide by iota in right hand side, which is equal to -2 iota upon iota square pi, which is equal to 2 iota upon pi. And that's the answer. So you see, we start with the routine integral and we got the answer in terms of iota and pi using principal value. Thanks for watching and give your precious time to this video.